All right, so we are in Unit 6, Learning Objective 7, which is to compare and contrast between real and ideal gases. So, couple of definitions. An ideal gas is kind of this theoretical gas, and it's in theory, essentially. So, an ideal gas will obey all gas laws under all conditions. This is of temperature and pressure. Volume of molecules for the gas equals 0. Force of attraction between the particles is 0. A gas will deviate from an ideal gas at low temperatures and high pressures. And this is when it will become a real gas. Kinetic energy for an ideal gas is constant. So you have elastic collisions. This is where you don't lose any energy in collision. Your real gases will not obey all gas laws under all conditions of pressure and temperature. Volume of molecules is greater than 0. The force of attraction between particles is greater than 0. At high temperatures and low pressures, a real gas will act like an ideal gas. Kinetic energy is not constant. So you have inelastic collisions. Now, both ideal and real gases are types of gases. They have the same variables, such as pressure, temperature, volume, number of moles. They have the same properties, such as low densities, fast moving, and high kinetic energy. And they can behave like the other gas under certain conditions. Now, one thing to note is that all gases are real gases, but they will act ideal at high temperatures and low pressures. As a gas condenses, or solidifies. So like if it is undergoing, this would be condensation or sublimation, is when it will deviate from ideal behavior. However, as long as the gas remains in the gas state, it will be an ideal gas. And as a gas changes state, it will become a real gas. So this was learning objective 7, which was to compare and contrast between real and ideal gases. Again, all gases are what we would consider real gases because they can change states of matter. If a gas could not change states of matter, it could not be a liquid or a solid, then it would be considered an ideal gas. However, as long as a real gas is in the gaseous state, it is ideal. It follows the gas laws under all temperatures and pressures. The volume of molecules would be considered negligible, and it has 0 force of attraction between the molecules. As soon as you start changing your state back to a liquid or a solid is when you deviate from ideal behavior. Okay, so that was learning objective 7, to compare and contrast between real and ideal gases.